everybody. Good afternoon. I know I'm interrupting your lunch, so thank you for spending some time here. Hopefully, it would be valuable. What I'm going to focus on is on the security, but I'll also have some pieces sprinkled in for observability as well as potentially search. So covering the entire Elastic stack. Um, as Jeff mentioned, big fan of Elastic. I have been using it personally for last 5 years now, and I have consistently enjoyed the process of learning new things. Even today, what Ben talked about, Shai talked about, I cannot fathom how crazy it is to constantly bring new features um, every release. So I'm very excited about it. Um, I'm going to talk about a teenage bug. It took 17 years for Microsoft to identify this vulnerability. And if you are in the room somebody who deals with security, this is a nightmare scenario. I would put you in sort of my shoes, what I went through, and then what are some of the lessons, how can we avoid it in the future. That's the focus. That's me. Like I mentioned, I am Elastic certified. I have spent 15 years in security research, and security is something that I love passionately. Just I would like you to think about what I saw right here on my left is a graph where you have, on an average, 50% of vulnerabilities that go undetected for 55 days, which is a scenario which is very common. This is survival analysis published by CISA. And then on the right, on my right, you see all these big vendors from Microsoft to Apple to Linux. Funny if you see SAP has a mean time of about 900, which tells you how crazy all these vendors are. Sometimes they are not able to get to all those vulnerability at the time. This is the number that I have it from the Elastic's own report. This is the threat report that they publish, which is, by the way, world class. This is a lot of security research put in for you as customers, as partners to leverage. And I'm going to focus on the 17 years of undetected. It impacted millions of servers, but I'm going to talk about DocuSign, which is what I was working on a Tuesday afternoon, sipping my coffee, and this bug popped in. I'll also quickly talk about the landscape. I have a quick demo to show if we have time, and then I have some takeaways as well. All my code is on GitHub. I'll share the links so you could actually use it today after the end of the meeting. So just as a timeline, the DocuSign is a sort of digital necessity. It's almost where if you are going to send documents, it is mostly through DocuSign. They own this area. And responding to like a 10 on 10 CVSS critical vulnerability is number one priority. The impact of it is on millions, if not the entire population of DocuSign, which is right now, as this stands, it's about close to 300 million users worldwide, which is almost the population of US. So this is just a quick summary. It's a bug that was discovered by a research team on Windows, which is a since 2003. It's a warmable exploitation. So what warmable means is that it can move from both laterally and horizontally on different servers, which is very difficult. About 150 billion in transaction. I had, and less than 48 hours. I've written 48 hours as a roundabout, but I didn't have any time to respond when this bug popped up. It was called SIGRed as a bug. The May 19 was when it was disclosed to Microsoft. The patch release happened in July, and then July 16th is when they had a first public POC. Now, the impact is pretty big. As I mentioned, it's all Windows DNS Server, which is almost at this point about close to 53% of all the servers. And then it has Active Directory dependencies and also Kerberos service that gets impacted too. This is probably a diagram I'm going to spend a decent amount of time, which is what I started building when I had to do the initial root cause analysis. So we all know about what is now called ECS. Previously, back when this bug happened, ECS didn't existed in its current glory. It was still manually developers plugging in the code, managing the schema by themselves, trying to troubleshoot as we go. So it's mature now, but it was not as mature back then. So it was a nightmare for me to understand first all of on your left. So these are the systems. So all these systems are providing details, and I was tasked to look at the data ingestion, do a deep understanding of all these events that are happening in real time, leverage now what we call Elastic's detection engine. Previously, it was ECS schema that you would write a Python code on. So, and then you send the alerts on Kibana, and then identify through alerts in real time what exactly was the cause of the alert. It could be all of these, including APMs and firewall issues. In my case, it was mostly related to servers. Finally, we had automated case management at DocuSign. This was a policy as an SLA to their customers. So if it's a known issue, DocuSign would like you to make sure that this is educated across the board. So they take the responsibility, which I love about a company, not unlike today's vendor, which they just say, oops. I'm going to do some live demo as well, but before I do, I want to give you just the foundation. Who here have played with detection rules in Elastic? Okay, cool. So there are a few people here. That's great. Detection rules for the rest of us are a new way how Elastic automatically does the identification for you. So once you write a rule, you could actually create a scenario on your, let's say, PagerDuty, on your sort of downstream system to detect those. This is extremely helpful for people who, like us, get extremely busy, and they have this, what Shai called the alert fatigue. So these rules help you and understand the signal properly. It's very easy. You create a rule right now. This is a new version, but previously what you had to do was write a lot of sort of manual code to do this. Right now, you could actually use KQL, which is the query language. In simple sense, you can write, let's say, or pick up index patterns. It's as simple as writing SQL query, and it's drag and drop for you. This is how the dashboard looks like. Typically, on your right, this is sort of how a scenario for me looked like, where you have constantly a lot of data poured in. There are also type of DNS requests. I'll show you specifically this diagram, and this also would be shown in the demo shortly. This is the flow, which I believe as an engineer, as somebody who understands security, all of us has to follow, right? We understand, let's say, for example, network traffic, decode all the protocol, understand and try and make sense of all of this data in a more sort of holistic sense, because you don't want siloed data giving, like, let's say, DNS information once and then network information somewhere else. So the flow, ideally, I would want is to have an automated way to extract meaningful information without me digging deep into it. And that's what I'm going to show you in a demo. By the time you're done in another 10 minutes, you would be able to create it very easily as well. Just one more critical insight that I want to share. The vector analysis is an area that troubles most of the threat hunters, which is how do you understand what is the right signal and what's sort of is a false positive. And this is where Elastic's new feature that I'm also excited about, which I'm going to demo in a second, is able to create that uh, true signal from all the noise that you would have. Finally, I'll show you how the KQL rules are built, and then you would have specific use cases that I'm more than happy to take questions on. So let me just talk about the real data right now. This is something that I put together. If you see, this is what I was showing a second ago in terms of different types of requests. So these are query types. So if you have hosted a website, or if you go to any website, these are sort of the basic information that you need, like CNAME record, triple or quad A records, TXT records. The challenge with DocuSign was that we were having these TXT record, and all these records individually do not mean anything, but as a group, it can tell you where and how the attack is happening. In our case, it was a big exploit that we were able to identify before our customers did. I have some data points here as well in terms of how the traffic pattern analysis works. Um, this allows us threat hunters to be able to detect what is a good website versus what is an attack site. And it all depends on how many times, let's say, a particular alert is being triggered, what's the traffic. Like, for example, if you have, let's say, jpmorgan.com, and you have a website that's pretending to be JP Morgan, your customers are going to JP Morgan website, but they don't know. So you could analyze that very easily. I'll also show you the alerts here. So usually I have created alerts already because it takes some time to identify how these are created. I'll show you in a second, but these are pre-made alerts for you to identify what are some of those false positive as well as the signal versus noise. And this is where sort of the magic happens. This is the core takeaway, hopefully, you could take from me in this conversation is how would you be able to detect, or how would you be able to identify what is the right rule to write? How do you specifically define what is bad actor versus a good actor? So I'll give an example of this particular alert, which is DNS queries for suspicious query types. Here, I have given example of TXT, null, but it could be any query record that you could write. So for example, if I have to edit the rule, or if I have to create the rule as part of the demo, what I'll do is I would give it a name. This is how easy it is. If you understand the fundamentals of SQL, or if you have a sort of a logical structure of what are your attack vectors, what is good actor, what is a bad actor, you could actually break it down. And you would have a rule here. What Elastic under the hood does is creates all the APIs. It creates all of the core attributes that you need in order to make this alert more effective. So this is where the query is defined. You have the count. So all I'm saying is for all the documents, if for the last 5 minutes, if it is above 1, create an alert, right? And you can go into the specifics of the API request. Again, this you don't have to do as a developer. Um, all of this is under the hood Elastic's magic that is being built. So if you see here specifically, you have the index that you have defined. You've created what the query is supposed to do, including, so here we are looking at the network traffic. Essentially what we need to see is, hey, in my DNS, tell me what's good, what's bad, what are some of those signals that would tell me this is a bad actor versus a good actor. And in addition to that, you have a MITRE and attack based workflow automatically built in. So you do not have to worry about other 70 plus sources that they publish. It's all automatically built in for you. And that's what I did when I had this exploit identified. I looked into what are some of those sort of use cases of a good actor, a bad actor, what are some of the attributes that I can monitor today and create an alert and let our team know that, hey, this is the exploit that we need to fix ASAP. I'll discard it. Similarly, I have a few more examples of rules that I would like to show. This one is a very tricky one. Imagine you are trying to find a very particular book, and it's in the library. All you know is the protagonist actually gets killed in the end. Now, this is the query that you would have to write. It's in a network data, which is petabyte in this case. If I have to tell you, okay, find a sort of orphaned child processes, it's just like that, finding that protagonist in a library of millions of books. It's a scenario that's very hard for anybody to fathom, but in Elastic, you could do that very easily on top of petabytes of data. What I am going to show you is the rule that as a demo, I created. So what I'm trying to do is first understand what is the event category. So here in this event category, I'm looking at all the process and event action happening at entire DocuSign system. This is, again, millions of records ingested in real time. Now, once that's done, identify what process started and what process ended, and if there are any child processes. Like, for example, I've given cmd.exe, PowerShell.exe, but here I'm trying to replicate what an attack was like. So it is a highly sophisticated process, but returned in a very simple query. I'm looking at all the documents, but you could identify, look, I only want to look at the top line and say, hey, for all these 20 queries or 20 documents, 20 million records, 200 million records, find and throw an alert. As always, you can define alerts here. If you are like me and live in Slack, you have ability to connect Slack as well, or PagerDuty, or your Jira tickets. So in our case with DocuSign, we were able to create case and say, look, this networking team fix this because this is a problem happening right now. So we have a ServiceNow integration right here, and also Slack integration with PagerDuty. That gives me a complete control on when the alert is happening, how the alert is happening, how is alert identified, and then finally, what are we doing to mitigate that alert? I only have a few more minutes, so I'll quickly go back to the slides here. This is what I showed you, but it's on this slide, this is more sophisticated. This is a lot of real data. I am trying to identify with Zeek or any other tools that you have. FileBeat is extremely powerful. It does the detection for you. You can build the logic very quickly. Same thing here. It's the network data. This is the architecture. Again, it's a sample architecture that I built. What components did I use? So I started with primarily the Elastic Stack. That's the sort of how all the events are captured. As I mentioned, there is some observability piece to it. For understanding the Windows, WinLog Beat is your friend. Anything related to Windows log, you'll have it. Packet Beat, just to make sure there are some DNS records, there are some orphan records. You could get it through Packet Beat, and then Zeek and other integrations as well. If you are adventurous, you could use other records as well. For example, if you have data coming, from other complicated sources, you could use Logstash as well. But beats are more lightweight, gets you from 0 to 1 very quickly. These were my requirements. So my boss, who was the CISO, said, look, BK, these are the things that we need to cover. And for the future, how do we take care of $150 billion of transactions in the future? So these were some of the things that I covered. Hopefully you could use it as well. And then make sure that we are not getting that alert fatigue, which I talked about. And I'm very excited with potentially using vector data, potentially using, VectorDB to be able to even add more specificity to my alerts. So if I'm identifying alerts, how do I prioritize it, create a workflow, and automated remediation? So as I mentioned in my first slide, 55 days to take remediation. Let this not be your company, right? Hopefully through this, you could remediate quickly, identify network anomalies, identify the processes that are spawning. These were my success metrics. You can enumerate that. The goal was, so I was 2 days old in DocuSign when this happened. So when I was done, this was a success metrics I created, which was 0 successful exploit, which is when I left, this was the case, the detection accuracy, as well as the false positive rate, all thanks to the Elastic. I have some, again, more real-time data for you, but we were able to understand these are the top 10 patchable vulnerabilities that happened. As you can see, the score, it's already here. I had all of them on 10. We were now getting to like 7 and some 5s as well. 10 means that if you don't fix it, your services would go down for sure. That's a path forward for us. Identify and deploy detection rules, monitor DNS traffic, and implement response. These are my takeaways. Like I said, a lot of my slides are my code is already on GitHub, and you would have all of these details. So the KQL rules that I showed are already on GitHub. All the configuration for future threat hunting. So in case if you want to use it, build it for your organization, you could do it, make it ready. For Elastic 8, this I just added after today's announcement. I'm very excited that there are new mappings that are available that you could use through Elastic. And that's the power of shipping quickly. Performance benchmark using BBQ. I'm on that bucket. Hopefully, we will be able to see if the performance improves. And then hopefully, if you are someone who is a consultant, can show some ROI to your business, to your team that, hey, this is what we could avoid if we implement these new rules, new alerts. So with that, I want to thank you for your time. Appreciate you coming.